So now we're finally ready to talk about logarithmic functions. We take a look at those exponential functions, think back to those graphs that we've got. We've got both versions of those that would end up being 1-to-1. Therefore, both versions that would end up having inverses. We don't necessarily need at the moment to split them up. If we talk about our f of x equals b to the power of x, we have our basic steps for finding the inverse function that begins with replacing our function notation with the y. So y equals b power of x. Switcheroo the x's and y's, x equals b to the power of y. But we would need a way to get the y by itself, and there wasn't one for a long time until the early 1600s and a guy named Napier who said, oh, you know what? I'm going to create something. I'm going to call it a logarithm, and the logarithm is going to be equal to a power, and that's how that's going to go. We're going to give it this kind of notation. So we've got this logarithm, which we're abbreviating log. We've got the base b that still shows up and is referenced with that exponential function. We're going to read this like function notation, f of x, g of x, log base b of x. So there's that idea. X is inside. It's being put inside of the machine. F of x, x gets put in the machine f. G of x, x gets put in the machine g. Logarithm base b of x, x gets put into this logarithm machine. So we're keeping a lot of these sorts of traditions and conventions. If we have that special base, that natural base e, then we would call it a natural logarithm. Instead of saying log base e, instead of saying log base e, that gets shorthanded. ln, like logarithm natural, natural log of x. But we also have, because of our number system, the common number system that we use is a base 10 decimal number system. That's common. So if we have a base 10 logarithm, we'll call that the common logarithm. This would be the only logarithm where we do not write a base. So natural logarithm, it's not log spelled out, it's ln. So it stands out on its own, doesn't have a base. log, no base, automatically means common log, automatically means base 10. That's the only time we see the log without a base. Log all by itself, base 10, common log. So we have these kinds of traditions in place. So when we talk about those being inverse functions, that's going to have an impact on the basic characteristics, transforming the basic characteristics of our exponential functions into our basic characteristics for our logarithmic functions. The domain and the range are going to get switched around because of that xy switcheroo that happens. The y-intercept, x-intercept, those things are getting switched around as well because of the xy switcheroo. The horizontal versus vertical asymptote getting switched around. The shape of those graphs, we talked in our video about the inverse functions, how we can take a graph and change it into its inverse function. So taking the blue shape that we had seen for our exponential function, transforming it into its logarithmic inverse version, taking the other green version of our exponential function, and so those bases, those are matching up. We get those different shapes. Hey, flip, 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 flip. Yeah, huh? Yeah. Same shape as here, just flipped upside down. Take that blue graph, flip it upside down, boop. So that's the stuff that we've got. Again, like we said before with our functions, we'd be interested in all that transformation business, what kind of stuff happens to our list of basic characteristics when we start making those changes to the function. How's that going to impact with changes to our graph. So we can look at, we'll just do one example in this particular case of how everything plays out. And again, the order of operations is having an impact on what stuff we're doing. So, excuse me, there is a little give and take here. We didn't necessarily directly follow the order of operations. For instance, you say, well, Mr. Brown, according to the order of operations, wouldn't we do the +2 first? It's true, we would, but I didn't do that first. I did the flip first and saved the shift for afterwards. Mostly because when we think of flipping something upside down, just literally flip it upside down based on, well, automatically that x-axis. And if we've already shifted stuff around, might be a little bit more likely to lead to a mistake. So I do like to say, you know, hey, maybe consider just doing the flippies first. I got to flip upside down because of that negative. I got the +2 referring to a shift left 2. I got that -4 at the end referring to a shift down. So if we take that basic blue graph because of a base 5 and start with that, we've got our x-intercept, we've got our vertical asymptote. If we flip that sucker upside down, no big shakes, nice little basic flip maneuver. Then we start messing with things more substantially by shifting them. If we do the shift left, then that's going to change any of our x stuff. Any of our x stuff is going to be shifted left too. So, x stuff gets shifted to the left. Subtract 2. 1 minus 2 is -1. X stuff gets shifted to the left too. 0 minus 2 is -2. Shift down, well, that's not going to change the vertical line. You take a vertical line and shift it down 2. It still looks exactly the same. But you take that blue shape and shift it down, excuse me, not 2, but 4. Nice try, right? Shift it down 4. Now, instead of -1 comma 0, the 0 is getting shifted down 4. 0 minus 4, oh, that's a -4. If we had other points that were along our blue curve, then we would need to make sure that we're shifting those as well. But this gives us a very rough idea of how things would look once we play through all of those transformations. So still got those transformations in effect. Again, we can also graph stuff on our graphing calculator, but it becomes a little bit more of a challenge with the logarithms, and we need some other stuff at our disposal. So we've got that coming up as far as giving us a little bit more versatility in graphing things with the graphing calculator that we don't have at the moment, because our graphing calculator doesn't allow us to just type in whatever base we want. Our graphing calculator limits us to either that natural log or that common log. Those are the only two that we can type in directly. So at the moment, we wouldn't have another way of doing this kind of sketch. We would need a little bit more in the way of logarithms to get us there.